From Here to the Stars, a video series created by the Tennessee Valley Interstellar Workshop. The TVIW is a non-profit organization dedicated to thoroughly exploring the science and engineering that can eventually open up the reality of interstellar travel. I am your host, Euin Cobb. Our guest today is Dr. James Benford. Dr. Benford is president of Microwave Sciences, which deals with high-power microwave systems from conceptual designs to hardware. His clients have included NASA, DoD, and many familiar aerospace companies. His research now concentrates on beam-powered propulsion for spacecraft. He has written 139 scientific papers and 6 books on physics topics, including the textbook High Power Microwaves, which, as of January, is now in its 3rd edition. His doctorate is in physics from the University of California, San Diego. I began the interview by asking Dr. Benford to describe his book, Starship Century.
It was an anthology of technical pieces and fiction, all of them looking at the prospect of interstellar travel, both from the near-term perspective to all the way out into what that would mean in the Starship era. And it involved about 19 pieces and therefore 19 authors and writers and a lot of artists. And it even has one poem by Jeff Landis.
Of course, you've heard of Stephen Hawking's announcement a few days ago concerning the breakthrough star shot. Because his descriptions are so similar to things I've read and learned about from the Tennessee Valley Interstellar Workshop, is there some crossover? Is there some mutualism there?
Well, there certainly is a relationship between the book Starship Century and Starshot, because as Yuri Melner tells me, it was very influential in getting him to start the Starshot program, especially the piece I wrote called Sail Ships, which was an advocacy piece that started by saying the first starships will be sail ships, that is, beam-driven sails. And in fact, that seems like it's going to happen. And that I wrote that only 3 years ago.
My greatest familiarity with propelled craft, very small craft, is using lasers when I interviewed Dr. Philip Lubin, a few months ago. This is almost exactly the same thing he's described, but I've noticed that a lot of your career has been based on high-powered microwaves. So what is your take on this? Is it most likely to be laser-based or microwave-based propulsion?
I think it depends upon which application one wants to do. The lasers tend to be preferred for very high velocities over very long distances, like starships, because of their focusability. In practice, in the experiments we've done, we've always used microwaves because the technology is much more available, much cheaper to use, and doesn't have some of the drawbacks of lasers. And it's a technology that's very well understood and very well developed, therefore also less complex and less expensive than lasers.
So in some cases, is it that it's easier, or is it that it's cheaper, or simply impractical to go one way or the other?
Well, all come into play, and I feel that this whole field should not focus very much on exactly what frequency you're going to be using in 10 or 20 years, because the physics doesn't tend to depend too much on the frequency. The practical aspects tend to dominate when you talk about actually doing experiments, because you have to consider the availability of equipment, the price of equipment, and the various aspects of using equipment. For example, in lasers, you have a lot of safety regulations because lasers can really hurt people.
Mm-hmm.
You don't have that in microwaves.
Oh, okay. Okay.
I mean, the microwaves you're using probably right now is, for example, the cell phone sitting in your pocket.
Mm-hmm.
That's a microwave device. You never think of it that way.
Mm-hmm.
It's fairly low power and it doesn't have any harmful effects. And also television towers use microwaves for transmission. Satellite transmissions are in the microwave because there aren't a lot of safety questions, and they're ubiquitous. There are no propagation questions either. They propagate through the atmosphere without loss, essentially.
Yeah, a lot of times I think people, when they hear microwave, they think of like it's one frequency, but we're talking about a band of frequencies.
A very great band of frequencies that goes all the way down from, well, let's speak in terms of wavelengths of several feet down to wavelengths of a millimeter, which is a very small fraction of an inch. So the enormous range in frequencies available, and therefore of different technologies to generate them. That happens to be my area of expertise, is high power microwave devices.
And mentioning the phrase through the atmosphere, some of the machines that have been proposed, or projects that have been proposed, have the power system in Earth orbit. Is it possible for the power system, the propulsive system, to be on the surface of the Earth and still propel the craft?
Oh, yes, certainly can. In fact, we tried to do an experiment on propelling a solar sail, which would be in orbit, from a ground based radiator, the Deep Space Network radiator down at Goldstone in the Mojave Desert in 2006. However, the sail didn't reach orbit, so we never got to do the experiment. You certainly can propagate microwaves easily through the atmosphere and propel a sail, and you can do the same with some frequencies of lasers and the ones that propagate well in the atmosphere, of course. And there will probably be such experiments done in the next few years as part of Starshot.
I'm wondering, because you're really into the technical side of this stuff, is there something that needs to be invented or overcome in order to actually reach a point where we're ready to launch? Are the hurdles technical, or are they maybe political, or what might block the project?
Well, they come in every variety. The technical are, I think, the hardest, and they're more technical than political questions. There, of course, unmentioned goes the economic question. The technical questions go all the way from the ability to focus beams adequately, to be able to track a target accurately over long range, and questions about how high an acceleration the sail can survive. I think, in fact, the sail is the hardest part of the system. Not that the others are trivial, but the sail has to have many properties work simultaneously in order for the application to make sense.
In your opinion, and this is very speculative, but I'm curious, if the government was behind it and there was plenty of money, how soon would it be possible to launch? Are we talking 5 years from now, 10, 15, 20?
If we're talking about Starshot,
Mm-hmm.
it's not intended to have the government be involved. And I think increasingly in space, it's going to be more and more private enterprise and less government involvement. But I think if we're talking about near-term applications such as launching into orbit using directed energy or raising low Earth orbit spacecraft to a higher orbit, that's doable within a time scale of about 10 years. If we go all the way out to Starshot, launching probes to Alpha Centauri, the basic estimate is 10 years to do the research, 10 years to build the system, and then you launch. So that would be 20 years from now. And of course, if you're going to Alpha Centauri at something like 2/10 the speed of light, which is the baseline concept, it will take over 20 years to get there. But that does mean that we could have a probe at Alpha Centauri by mid-century.
There's been a lot of talk about different sizes. The Starshot, the first few articles I read sounded like they wanted a device about the size of a cell phone. When I talked to Dr. Lubin, he was talking about a device as small as 1 gram. I mean, different ones, of course, have different advantages. What's your expectation of what might actually be the right size or the right compromise size, so to speak?
That's like asking what's the right size for an automobile.
Okay.
In fact, you can see what the history will be. The first ones will be larger than the later ones, and they'll be more massive than the later ones because we'll get better at it and the technologies will improve. I don't think it's important just where we start because technology will change enough over the next few decades that we have no idea what the size and mass will be in the ultimate applications. For example, let's go beyond starshot. What do you do when you're just doing flybys? You're taking photographs in the data back. Fine. What if you would actually like to get more interesting data, so you make somewhat heavier craft and it'll go a bit slower? Then you ultimately might want to figure out how you could decelerate it and get into orbit around planets of Alpha Centauri. And so you would use a very different kind of craft. So this will be a continuing thing. It's in a way, it's kind of like asking the Wright brothers, gee, how many passengers do you think an aircraft will be able to carry ultimately?
Yeah, I guess so. Yeah,
And if
yeah,
you said 500, they would laugh.
yeah. Yeah, too early days. When I think of a flyby mission, at least currently, I mean, we've done wonderful flyby missions like in the 70s and the 80s, but one most recent that comes to mind is the Pluto flyby. We saw only one side of the object, we saw it in great detail, and the data keeps coming because the distance and the bandwidth requires a longer period for transmission, even though the event was over like in 15 hours or so. And the Pluto flyby produced a huge amount of excitement because of the surprises and the things we learned. Is that your vision of what the flyby of another solar system might be like?
Oh, yes, just very much like that. And tantalizing because going by at a fraction of the speed of light, you got at best perhaps an hour of observing time and perhaps many, many months to transmit that data back. It will be very tempting and tantalizing
Hmm.
to see a new set of worlds and then they're gone.
Yeah, yeah.
But of course, we will have launched other probes since the first one, and there will be other ones coming. And a month or so later, there will be another flyby. And so it's going to be like a series of snapshots.
I would love to see 1,000 probes heading off in 1,000 different directions. That would be awesome.
Yes, well, there will be ultimately, I think. Sail ships make so much sense that the physics is understood. The engineering is challenging, but there doesn't seem to be a fundamental showstopper. And then the cost is even understood pretty well. We know how to optimize the cost of such systems, and it gives us a range of costs depending upon how much mass you're going to accelerate to what velocity. That's basically what it is. It depends upon mv squared.
What experiments are you looking forward to being conducted in the near future so that we'll sort of zero in on how to overcome the problems that maybe remain and also to sort of fine tune the plan?
To me, the most important thing going forward is to do more experiments on the stability of a sail riding on a beam. That you don't want the sail to fall off during the acceleration phase.
Mm.
We did early experiments over 12 years ago at the University of California, Irvine, my brother and I, in a series of experiments, and have pretty well determined what the parameter space is for stability for certain shapes of sail. And that stability requirement places real requirements on the sail in terms of its size, its shape, its materials, and the distribution of mass across it. All of these factors come into play, and they vary depending upon how fast you want to accelerate the sail and what the frequency of the beamer, what I call a beamer, the thing that generates the beam, what that frequency is. So that needs to be addressed early on because I think it's the major constraint in the system.
Yeah, I think it's tempting for a person to think about this as it's a light sail, therefore it's a gentle acceleration, but it's not. How much of a force are we talking about?
Well, us put it this way. In the experiments that we did in 2000, the first experiments that lifted a sail and flew it in the laboratory, in vacuum, of course, we were using a kilowatt per square centimeter. Now, the the sunlight on Earth is over a kilowatt per square meter. Now there are 10,000 square centimeters in a square meter, so we were 10,000 times more intense than sunlight. That's the kind of level we're talking about.
Okay. And do you have any idea what kind of acceleration that produced?
But we got up to about 13 Gs.
Wow.
Well, you have to get up to one. You have to get up to 1 G to lift off. Okay,
Yeah.
so that's openers.
Yeah. Yeah.
We got to 13 Gs and it bounced off the ceiling of the vacuum chamber.
To actually go to another star at a reasonable time period, how many Gs is this thing going to have to suffer?
Well, the Starship baseline concept is 60,000 Gs.
What?
Uh,
You're kidding.
no, no, I no, I it's true. It's a very, very large number, and the reason to pick such a large number is to keep the size of the beamer down to something you can think of building. And as it is, with a small sail of a few meters across, you still have a kilometer scale beamer on the ground.
Okay.
And part of that is that you start at a range where the sail is a long way off up in space before you even start accelerating. So those are the trade-offs. I think that realities will probably drive the system concept back toward lower accelerations. That's you see a level that the only thing that reaches those levels in anywhere else in civilization is artillery shells in the barrel of the gun.
Yeah.
Serious accelerations.
My first impression when you said that kind of G's, I'm thinking, how do you keep from vaporizing the thing by putting so much energy into it?
It is certainly true that the sail material cannot afford to absorb more than perhaps 100,000th of the laser hitting it,
Wow.
or it'll suffer a lot of damage, melt, vaporize. So it has to be almost perfect reflector. In fact, perfect would be quite nice.
I would think. Tell me, have we ever created a surface that was that reflective?
I am told that there are mirrors that are that reflective. Of course, they are not, they are very specialized. They operate at specific frequencies and they are not light, they're not thin.
Oh, okay. That's an additional option by making them reflective at a specific frequency.
Well, yeah, not really, because as you accelerate,
Hmm.
the frequency of the laser beam seen by the sail is Doppler shifted.
Yeah.
So if you're going up to a tenth, say, of the speed of light, you're going to see a tenth shift in the frequency of the laser. So you can't be building a sail that's reflective at only one frequency.
Wow. Yeah. This sounds a lot harder than I thought originally.
It is hard. It is
Yeah.
very hard.
Wow. So,
But I didn't say it was impossible.
yeah, that's true. Is that the hardest problem, keeping the thing from absorbing too much energy, or are there other problems even tougher than that?
I think the sail stability is of same order of magnitude of difficulty. I think control of the laser aperture in the sense that all these things are in phase and all radiating at just the right place across a vast expanse of beamer surface. I think that's a hard problem too. And so there's plenty of work to be done.
Okay, okay. Is there any chance that it could be made ablative, the surface?
Well, if you do, first of all, it's going to cease being a very reflective surface after a while,
Yeah.
and you get only a little delta V, that is, increase in velocity from ablation, because it's really just by making the sail into a rocket
Oh, yeah.
with a limited exhaust velocity. And the rule of thumb for rockets is that you can get to 2, 3, 4 times the exhaust velocity, and that's all you'll get out of a rocket.
Well, before I let you go, let me ask you, even with all the hurdles, you're confident that this is a real possibility that we can genuinely do?
Yes, I am actually. I think we're on the road to the stars.
Excellent, excellent. Thank you for taking the time for the interview, Doctor.
Thank you.
That was Dr. James Benford. I have been your host, Stephen Euin Cobb. If you enjoyed this video, please click the like button, and you can subscribe to our channel for more such videos. On behalf of all of us here at the Tennessee Valley Interstellar Workshop, I thank you.